One last thing for section 3.4. Just we had a special rule for factoring the difference of two squares. There's also special rules for factoring the sum or difference of two cubes. So for example, the sum of two cubes, if you have two terms like a cubed plus b cubed, you can break it down into two separate groups. One is a plus b, so whatever the cube root of those two terms is, times a squared minus a times b plus b squared. The difference of two cubes is pretty much the same format, we just changed the sign of a couple things. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So let's see if we can figure out a pattern here on this first one, 125d to the third minus 8. The thing I would strongly suggest for both of these, or for any time you come across a problem like this, is to break it down into writing each of these as one cubic term. Now, 125d cubed already has a cubed in it, but I want to make it a little bit more succinct. If we make it 5d cubed, because remember, if you have 5d, that's one single term being raised to the third power. Both the 5 gets raised to the third and the d gets raised to the third, which, if we did it, would give us back to the 125d cubed. Then the 8 we can write as minus 2 cubed. So if it helps you putting this into perspective, it's like our a value is 5d, oop, that was sloppy, 5d, and then our b value is 2. So kind of following along with the pattern we had, it was a minus b, so, I'll just rewrite the whole thing. A minus b times a squared plus ab plus b squared. So if we plug that in, we have 5d minus 2, and then 5d, well, I'll write that out, 5d squared plus a, so 5d, times our b value of 2, plus our b value 2 squared. Cleaning that up a little bit more, we got 5d minus 2, and then in the other one, 5d squared is the same as 25d squared, plus 5d times 2, that's plus 10d, and then finally we have plus 2 squared, which is plus 4. So that's as factored out as we're going to be able to get that problem. Now for the last one, it's going to look a little more challenging at first, but then I think we'll be able to figure something out. For this last one, we got 4x to the fourth plus 108x. Now, neither of those are cubic terms. X to the fourth clearly, it's got a cubic in it, which we'll get to in a second, but 4 is not a cubic term. Neither is 108. What you need to do anytime you're factoring is look for a greatest common factor. Looking at 4x to the fourth and 108x. They're both divisible by 4, and we can also factor out an x from each of those. When we factor out 4x from x to the fourth, we're left with x to the third. When we factor out 4x from 108x, you get 27. So we're going to leave that 4x alone. And then I'm going to convert the x to the third plus 27. I'm just going to rewrite it as x to the third plus 3 to the third. So now you can see it's that it's the sum of two cubes. So again, it's like our a value in this case is x, and our b value is 3. So if we write this out, that 4x stays there. And then we're going to start breaking down x to the third, x to the third times 3 to the third. So it'll be a plus b, so x plus 3, times a squared, x squared, minus a times 3, I'm going to write that out, a times b, I'm just going to write that out as x times 3, we'll rewrite that in a second, plus our b squared, so plus 3 squared. Cleaning this up just a little bit more, we got 4x still up front, x plus 3, that hasn't changed, x squared is already cleaned up, x times 3, we'll just write that as minus 3x, and then 3 squared is going to be plus 9. So that is as factored out as we can get it.